6G and beyond communication. So this is Gfdm. In earlier series, we discussed about the OTFS scheme. Today, we are going to discuss about Gfdm. So what is Gfdm? What it stands for? That is generalized frequency division multiplexing. So as the term indicates, this is also frequency division multiplexing. But why it is generalized? For that, we have to know OFDM. So OFDM is orthogonal frequency division multiplexing. Whereas GFDM, if we see here, we are going to use the orthogonal waves. So orthogonal waves we are going to use. So here non-orthogonal waves we are going to use. So orthogonal waves means each subcarrier is null is peak for the other one. So this way we are going to transmit in OFDM. But in the case of non-orthogonal, here the pulses are not orthogonal to each other. Here multiple waveforms will transmit at the same time. So that one thing it will be there. That is the difference. As here we are going to see here pulse. Here we are transmitting the information in the frequency domain in the square pulse format, and in the time domain we can observe it as a sync pulse. So these are the side lobes, and this is the main lobe which we can see in the orthogonal frequency division multiplexing. But in the case of GFDM, here the side lobes it has been removed by passing this one through the filter. So through the filter, if we pass, that is pulse shaping, we are going to do it. And with that, only the main lobe we are able to see. So only the main lobe it will be visible and side lobes will be removed. So what advantage this will give in GFDM? As we see, PAPR, that is peak to average power ratio, is an issue for the OFDM case, whereas in the GFDM, as the side lobes, which will contribute to the, when we will combine this one for the multiple subcarriers, at that time, these side lobes will impact on the peak to average power ratio. These side lobes will not be present over here. So due to that, peak to average power ratio will be low. So this one advantage it will be there. But as the advantages are there, there is disadvantage also present in the non-orthogonal. As these are non-orthogonal subcarriers to each other, so there is major chance of self-interference. Or so to avoid this, we have to use the self-interference cancellation techniques. We have to use it, and this one way we can reduce the self-interference, and the equalization can, and doing the signal processing, we can improve the overall performance. So this way we can improve the GFDM process. So what other difference we can see it in the GFDM? So in OFDM, as we see here, we are representing it with the time versus frequency. So these will represent the symbols. So there are total 14 symbols which will be present in one slot, whereas these are the subcarriers. So as per 3GPP specification, there are different combinations it will be possible, but in one slot there will be 14 symbols it will be present. In the case of GFDM, what exactly the difference is? Here the subcarriers will remain the same, but these symbols, whatever the symbols which are present earlier, those are getting divided into the sub symbol. So here total number of symbols may vary. That will depend on the 3GPP specification further. But these will represent into the sub symbols, and this will be subcarrier. So this information will be present in a sub-block information. So sub-block will contain the subcarrier. In one subcarrier, there will be many sub-symbols will be present. So why this will provide a benefit? One benefit it will be there, that frequency selective fading we can achieve by using, we can avoid it by using these sub-blocks. So if the particular channel is impacted with the particular frequencies, so that we can avoid it by using this sub-block concept. So there are some advantages and disadvantages which is present in comparison to the OFDM in case of Gfdm. And this is generalized frequency division multiplexing, as DFTS OFDM and the OFDM concepts are being used in this one. So this is the new waveform which is being proposed, and there are some advantages and disadvantages are also there, but we can consider this as an one waveform in future. Thank you. That's all.